So to get I, okay, some of you were right. That's just, okay, taking this 295, because that's up to here, minus 60, and then minus 180. Again, to illustrate, this is your I. 295 is this, right? So 295 minus this portion, which is 60, and then minus this portion, which is 180, that's how you get I. So 295 minus 60 minus 180. What's the answer? Correct, Geraldine. And Joshelle Reyes Lazaro. Okay, good. So 55. So now I got I. But again, the goal is to get I1 because I need that to get the length of curve for the first curve. So now I'm stuck, right? I've used up my azimuths. Now, if you're stuck, one thing you can do is look at your given again. We're given stationing, so let's use that. This reverse curve. And stationing at PC, 20 plus 304. So let's write that. This is 20 plus 304. And then stationing on PT is 20 plus 544. This is 20 plus 544. Now, if you remember, we have an equation for station PT involving PC. Station PT equals station PC plus LC1 plus LC2. Okay, so let's use that equation. Let's sub in station PT. So that's just 20 kilometers. So 20,000 plus 544 meters. So 20,544 meters equals same thing here, 20,304 meters plus. Now again, I don't know LC1, but I know the equation for LC1, which is IR. So let's rewrite this as I1 R1 plus I2 R2. I know R1. If I can solve for R2, then I'll get two equations involving I1 and I2. So now let's solve for R2 using this same concept. So 20 equals R2 D2. So 20 equals R2. R2, D2 is 5 degrees, but once again, we have to convert that to radians. So let's do that. And then please solve what's R2. Correct. John and Denzel Lahong Crystal. It's 229.18. Now this goes without saying, but please store these values in your calculator to make answers more accurate. Okay. So I1 or I, to look here at our notes, is also equal to I1 plus I2. So we can equate 55 to I1 plus I2. We have value for R1, we have value for R2, so we essentially have two equations, two unknowns. Okay? So that means we can use those to solve for your I1. Okay? So please solve for I1, and remember in doing so, since this is in degrees, convert that to radians first, and then the answer that you'll get for I1 would be in radians. Okay, so try to solve simultaneous equations. What's I1? Oh. Again, multiply this by pi over 180, you got an equation. R1 is this, R2 is this, what's I1? Now, for those having trouble using your calculator to solve for simultaneous equations, because you can do that, you can just use the equation mode of your calculator. Ax plus by equals cn. And in case you're having trouble, you can always do it manually. Oh, someone already got it. Correct. John and Denzel. Okay. What is skalahan? Who else got it? Also, Zalika, correct. Okay. So another way you can solve for this, instead of using your calculator, is by manually solving for it. So we can use this equation. You'll get I2 equals 55 times pi over 180, because again, that's in degrees. I want it in radians. Minus I1. And then you can sub this in 2. Okay? Which will give you 2544, 2304 plus I1 R1. Again, R1 is just this. Plus sub in I2. 55 pi over 180 minus I1. As you can see, only I1 is unknown. So you can solve for I1. And if you do that, you'll get I1 equals pi over 9. Okay? Or convert that to degrees, 20 degrees. Okay. So the reason you're gonna get I1 equals pi over 9, or for some of you got decimal, I think pi over 9 is 0.35. That's correct as well. That's in radians already. Okay? So now I got I. Let's solve for LC. LC equals IR. I already have the radian form of I. So LC1, I1, R1. So let's use pi over 9 times R1. What's the answer? Correct. Pauline. And Salika. Correct. It's 100. If you use stored value of this, you'll get 100. Okay, great. Now remember, our goal was getting station PCC. And that's just station PC plus LC1, because this is LC1. Station PCC once more is 20,304 plus 100. The answer to that is 2404. So to write that in station form, that's 20 kilometers plus 504 meters. And that's it for number 2 for compound curves. Do you have any questions? Please answer in the chat. Okay, no questions. Let's move on to reverse curves. Okay. Reverse curve. So reverse curve consists of two simple curves joined together, but curving in opposite directions, as you can see here. Right? They're opposite directions. The instant change in direction at the point of reverse curvature, or PRC, brought about some safety problems, right? So if you experience driving, a sudden change in curve or curvature makes it hard to steer your car properly. But despite this fact, reverse curves are still being used with great success on park roads, formal paths, waterways, channels, and the like. So not so much for highway roads, but it's still used in things like this. Okay, so equations for reverse curves are also the same for simple curve for your R1, I1, LC1. Okay, all the same equations, similar to your I2, L2, LC2, etc. We have this line, which is also your common tangent, and then the point where your two curves meet is PRC. For your compound curve, it's PCC. Here, it's PRC. And then let's get the equations for stations. If we're given stationing of PC, the beginning of your curve, to get station PT, that's just PC plus LC1 plus LC2. So it's the same as your compound curves. And then if you're given stationing of V1, that station PT equals station V1 minus T1. Now, if you've noticed doing that, V1 minus T1, you're just going back to station PC. So from PC to get to PT, again, that's the same. That's LC1 plus LC2. Okay? So again, that's the same as your compound curve, where you start at Pi over here minus X minus T1. Or if you're given station V for the first curve, that's just station V minus T1. So you get to PC plus LC1 plus LC2. So they're essentially the same equation. You just have to go back to PC and then plus the length of your curves. Okay? So that's reverse curve. Let's have some examples. Example 1. The perpendicular distance between parallel tangents of the reverse curve is 35. The back tangent has an azimuth of 270 while the common tangent is 300. If the radius of the first curve is 160, determine the radius of the second curve. Okay, we're given azimuths, meaning we can draw this properly. So back tangent is this. It's the back tangent of the first curve. Forward tangent is this. Forward tangent of the second curve. So let's start out with drawing those azimuths. So first, back tangent 270. Okay, start with that. So let's draw 270. So again, from south, 270 is just on this line, right? That's 270. 9, 18, 27. So that is where the beginning of your curve is. So let's draw a line hitting that mark. And then this is your PC. Next. Common tangent is 300. So common tangent. So that is where P1 and P2 have the same orientation or same path. Okay. So yeah, let's say this is the end of your P1. So this is P1. Okay. Azimuth of common tangent is 300. So measure out 300, probably something like that. And then draw your line. Okay. Remember, T1 equals T1. So measure out roughly the same length on this line. So something like that over here. So this is the end of T1. Okay. Oh, wait. 270. Like I said earlier. Okay, 90, 180, 270. So my back tangent should have been this way. Okay. Yeah. The more correct way to do it. Okay. And then again, estimate where your T1 ends. And over here, draw 300. And like that. Okay. This is your 300. And then measure out roughly the same length again as T1. So maybe here. Okay. And then this is your T1. And then there's another mention here. Parallel tangents of the reverse curve. So meaning, the back tangent and the forward tangent of your reverse curve is parallel. My back tangent was directly horizontal, so my forward tangent should be the same. Should be horizontal as well. Okay, so like that. And then this is my T2. Okay, So measure out roughly the same length on the other side. So maybe somewhere here. And that point is the end of your reverse curve PP. And this is your PRC. Okay? So those are your tangents of your curve. Now let's draw the actual curve. Okay. So remember, your curve is always facing away your vertex. So it's gonna be like that. And then it's gonna go oppositely. Yeah. Okay, so that's your how to draw your reverse curve. Now there's another thing given here. Perpendicular distance between the parallel tangents is 35. Once again, these are your parallel tangents. So perpendicular distance. So if I draw a straight line here, right? And this length is 35 meters. Okay? Or you can also just mark it here, right? Distance between those two, this is 35 meters. Okay, same thing. Right. And then let's just write the other ones. Given R1, 160. And the goal is to get radius of second curve. Okay. So, right. To get the radius of the second curve, let's see what parts of this given we can figure out. So we're given azimuths. Most likely we can get the angle of intersections. Okay. So let's see what we can get from angle of intersections. Okay, we have I1, R1. So the things we can solve for are E, but E doesn't really help us in getting R2, right? We can also use tangent. Now, if I can just get the tangent of the second curve, we can get the radius of the second curve, right? So this is the most probable approach in getting R2. So let's try. Let's try solving for that. Okay. So to get equation for tangent, again, I need I and R. Let's begin with trying to get I. Now, this is I. This is the I of the second curve, first curve. And then this is the I of the second curve, right? If you've noticed, these are the points of intersection of each curve respectively. Now you'll see, what can you say about I1 and I2 based on this drawing? What have you observed about them? Correct, Kian and RDL. Kiben, Lapid. Correct, Lahom and Furiskal as well. Lapid. Very good fight, correct. Okay. So they're actually the same. Why? Because they're actually parallel angles, right? They're from the same uh, line, right? Theorem on parallel angles. These two angles are equal, and that's precisely what I1 and I2 are. So we can write I1 equals I2. So very good on that observation. And now let's just solve once again based on the drawing. Can you give me the equation to get I1 or I2 given the azimuths? Correct, Jan? And Alyssa. Okay, Alyssa. But what's I1? What's the value of I1? Right? Was Oh, correct, Jasper. Who else? 60. Mm-hmm. Okay, yun lang. So if you've seen, to get I1, let's check here. This thing is 300. And this, right, is 270. So 300 minus 270, that's how you get I1. Okay? Because it's the same horizontal line, so it's going to have the same azimuth to that horizontal line. So that's why this is also 270. So 300 minus 270, which is just 30 degrees. Okay, now I have I1 and I2. I also have R1. So now the only problem is getting R2, right? Or T2. Now look here. Another thing that's given is this height. Okay. Now try to be creative. What kind of shape do we have because of this 35 meters? Or this? What can you see from the drawing? Very good, John and Kian. What is you? Okay, it's a. Oh, okay. And then correct, John, Kian, Denzel. Dami mo ng points though. And then Geraldine, correct. Lazaro. Okay, the answer is it's a right triangle. You see? And that forms a right triangle. So this height is 35, right? This angle, we can get that. That's just, this entire thing is 90 because this is 270. That's directly on the horizontal line. This is a perpendicular length between two horizontal lines, so that's directly vertical. So we can say this is a right angle as well. Therefore, this entire thing is 90. So to get that, that's just 90 minus I1, which is 60. Right? 90 minus 30, this is 60. Okay? And then, this hypotenuse of your triangle is T1 plus T2. Okay? So T1 plus T2. And as you can see, I can create an equation for T1, T2 using trig functions, specifically cosine. Cosine 60 equals adjacent, which is 35 over hypotenuse, T1 plus T2. Okay? So now before we continue to that, let's solve for T1 first, since I already got I1 and R1, so that we can continue with this equation. So T1, okay, try to memorize the equations to make your solution faster instead of always looking at your notes. So R1 tangent I1 over 2. R1 is 160. Tangent I1 is 13, so this is 15. Please solve what's T1. Correct, Sante? Oh, someone's mic is on. And Joshelle. Okay. The answer is 42.87. Okay, now store that in your calculator. And then input that here. We can solve for T2. Please solve what's T2. Correct, RDL. And yeah, yes. Correct, John. What else? Ang layo. Correct, Micah. Okay. It's 27.13. So once again, store. Now I have T1 and T2. We can use the equation for T2, which is R2 tangent I2 over 2. T2 is this. So I'll just write T2. R2. I2 is also 30. So this tangent 15. Oh, please solve what's R2. Hmm? Correct. Ang wala pa ang points. Sino ba? Correct, Micah. Who else? Correct, Angela. Okay, the answer is 101.24 meters. That's it for number 1, reverse curves. Do you have any questions? Please answer in the chat. Okay, there is a question. Ma'am, paano ulit yung I? Okay. Between the back and forward tangent of each curve, that is your I, angle of intersection. So this is the back tangent and forward tangent of first curve. And this is the back tangent and forward tangent of the second curve. Now they happen to be parallel, that's why I1 and I2 are equal. Yeah, so I is angle of intersection between the two tangents of each curve. Okay, so for reverse curves, that's it. Now take note for compound curves, we have I, okay, just I, which is, yan, this I1, this I2, if you extend the back tangent and forward tangent of the first and second curve, you get this I, okay, which is the point of intersection of the compound curve. Okay, and then point of intersection of first curve is V1, point of intersection of second curve is V2. Okay, we just gave it different labels to differentiate each point. While for reverse curve, that's not really combination of that because there's no intersection of the back tangent of the first curve and the forward tangent of the second curve. So there's no just capital I, angle of intersection for the entire reverse curve. Okay, so that's the difference as well in solutions for the compound curve. Okay, any other questions, clarifications? Okay. None. Let's have another one. Last question for today. Number 2. The common tangent BC of a reverse curve is 280.5 meters and has a bearing of south 4731 east. AB is the tangent of the first curve whose bearing is north 7245 east. CD is the tangent of the second curve whose bearing is north 3813 east. A is at PC while D is at PT. The radius of the first curve is 180 and its point of intersection is at station 12 plus 523.37. Find the stationing of PT. Okay, we're given a lot of bearings, so that means it's easier to get the correct form of your curve. For a given common tangent, again, that common tangent is this. We're also given bearing of AB, and A apparently is the PC, which is beginning of your curve. So you can start at the common tangent. I'm gonna start at A just because I like starting at the first point of each curve. So let's get bearing of AB. North 7245. Okay, let's do that. So north, this is the north line. Draw 72 degrees. Now let's say this is your point PC or your A, which is again same as your PC. And then and maybe this is your 72. It's not quite 90 degrees yet. So that's 72, 45. Okay. And then draw a line connecting to that marking. Yeah. So that's your AB. Let's say this point B. And then we have bearing of BC as well, which is common tangent BC, bearing south 4731. So from the south line, 47. So kind of like that. And draw a line to that. So 47, 31. And the length of that is given. Once again, let's try to measure out. This is P1. Measure out the same length, roughly the same length. So that point is P1 as well. And this is your PRC. Okay. And then that's your B. What else? Tangent. Okay, CD is the tangent of the second curve and bearing is north 3813. So C is the end of our common tangent. This is P1. Next, try to measure out another length P2. So let's say like that over here. That's the end of your P2. And this point is your point C. And there's a bearing for C to D. And so C to D was given as 3813. Okay. So 3813, like that. And then once again, measure out or draw out that line. This is 3813. And then estimate roughly the same length on the other side. And so this is T2. And then this is also T2. And this is your point B, which is the same as your end of your curve. Okay, now you have your tangents. Let's try to draw the reverse curve. Okay, once again, combine points. That. And then you're going to go the reverse way. So that's your reverse curve. Next, what else is given? Length of your common tangent is 280.5. So this entire thing, okay, is 280.5. I'll put it here. And 280.5. What else? Radius of first curve 180. So R1, 180. And another thing that's given, the last thing that's given, radius of first curve is 180. And its point of intersection is at station 12 plus 523.37. So it's here. This is the point of intersection of the first curve, right? This is the point of intersection of the second curve. This is PI1. This is PI2. Okay. And this has a station of 12,523. Point 37. And then what we want to get is station PT. Oh, you want to get this. This is your station PT. Ma'am, bakit bond dun yung PI 1 and 2? Oh, PI is point of intersection of the tangents of each curve. This is the back tangent of your first curve. This is the back forward tangent of your first curve, right? T1, T1. Point of intersection. And then this is the back tangent and forward tangent of your second curve, 2. Point of intersection here. That's why that's PI2. Okay? Another question is, paano nalaman na yung point sa second curve is andun sa likod ng BC? BC. This one? You mean, how did I know that's where PRC is? Okay, yeah. Because BC is defined as common tangent. By definition, common tangent is where PRC is all the time. Common tangent is where your T1 and T2 is. Forward tangent T1, back tangent T2. Always. That's the definition of common tangent. It shares the same azimuth bearing T1 and T2. Okay? Okay, that's how I know. Okay, again, the goal is to get this TT. Now we're given essentially a vertex. This is also a vertex. Point of intersection, vertex mean the same thing. They're just labeled differently to make distinctions. So it's the same as V1. Okay, point of intersection, PI, and V1 are the same. It's just a difference in labeling. So to get to PT, so we're going to use this equation given stationing at V1. So this station minus T1 plus LC1 plus LC2. Okay, so the goal is to get T1, LC1, LC2. Let's begin. Let's start with trying to get T1. Can anybody give me the equation for T1 again? Or tangent? Very good, John. And Geraldine. Our tangent I over 2. Correct, Jasper and Mark. Okay, it's our tangent I over 2. So I gotta get I. Because I already have R. So now I want to get I1. Okay, so I1 again is angle of intersection, right? This is I1. And now I want to get that. Now one way to get that is by looking at your given angles, which are bearings. This is 7245. If I extend that line over here, this is A, this is B, right? So this is also 7245 because they're parallel angles, right? And so they're equal. I draw another straight line here. This is your other tangent one. This has an angle of 4731. As you can see, this is what I want to get. This is your I1. So from this drawing, it's pretty easy to figure out how to get the equation for that. It's just 180 minus this and this. Okay? So let's put that into equation form. I1 is 180 minus 72 minus 47. Please solve what's the value of I1. Correct, Raymar and Geyser. De La Cruz Bernardo. It's 5944. Also, Gabriel. Okay, the answer is 5944. In the same manner, we can also get I2, so might as well get that in case we need it in the future, right? I2 would be this. If I extend that line, this is your I2. Okay, now using the same logic, this is the bearing of BC, this point C. I can extend that here because they're parallel angles. This is also 47. So I'm given this and this to get I2, that's just 180 minus those two. So let's do that. 180 minus 4731 minus this one, which was minus this, 3813. Please solve. What's the answer? Correct, Gabriel and KB. Sampan Escobar. Okay. So the answer was 94 degrees 16 minutes. Okay, I successfully got I1 and I2. Now, I got I1, R1, I can solve for T1. So T1 is R1 tangent I1 over 2. We got all of that. R1 is this, I1 is this. Please solve what's T1. Okay, good. Correct. Andre. And Geraldine. The answer is 103.37. Okay, store that. That's one of the things we need. Okay, right. Now I need LC1. LC1, what's the equation for length of curve? Correct. Very good. Maria and John. Dami na. Next one. Geyser. De La Cruz. Yeah. Correct. The answer is IR. I already have I. So I1, R1. So that's I1 times, remember, we also always multiply by pi over 180. R1. Please solve what's LC1. Correct, Maro and Raymar. Asople Bernardo. Okay. 187.66. Alright, now next is I need to get LC2. I got I2, right? And now I need to get R2, which I don't have. So now let's start with getting I2 first. Okay, so just take note, I need this later. So store that. R2. Remember, in our previous examples, one of the ways to get R2 is to figure out tangent 2 first. I got tangent 1. So, I'm given this, right? The length of your common tangent. So that means 280.5 equals T1 plus T2. I've got T1. Sub that here, please solve what's T2. Correct, Jan? Lahon? Wells. Colleen. It's 177.13. Okay, store that in your calculator. And then from that, we can solve for R2. T2 equals R2 tangent I2 over 2. T2 is this, I2 is this. Please solve what's R2. Correct, Raymar and Colleen. Okay, it's 164.41. And that's what I need in figuring out what LC2 is. So store. So finally, let's get LC2, which is I2 R2. And then we'll multiply I2 by pi over 180. Please solve what's LC2. Correct, Denzel and Raymar. It's 270.50. And that's what I finally need to figure out what station PT is. So, combining all of that, station PT equals station, this one. So, we call that PI1, which is again, that's the same as V1, vertex 1 or point of intersection, the same. Minus P1 plus LC1 plus LC2. Okay, combine all of that. What's the final answer? Correct, Jasper. Sante. It's 12,878.16, and to write our final answer in station form, 12 plus 878.16. And that's it for station PT. Okay. Do you have any questions? Please answer in the chat. Okay, there was a question. Diban, units. Yes, units. Yeah, no need. The formatting of your station is immediately in kilometers, meters. So even here, as you can see, even in the given, there's no given unit. So for stationing, it's just this. Because it's understood, this immediately kilometers, this is in meters. Okay? For anything else, for example, if we're looking for T1, yeah, you gotta write meters as the final answer. But for stationing, no need. Okay? Any other concerns, clarifications? Two of you asked the same question. No more? Okay. While waiting for clarifications. So that's it. On Saturday, you'll have seat work, number 3. Coverage is horizontal curves. Next week, Tuesday, I'll try to discuss vertical curves. And then next week, Thursday, earthworks. And then on Saturday, next week, modular exam. And then for the 11th week, all about oral reports. So all of your exams should be done by next week. And then again, 11th week, oral report. So for Tuesday, groups 1, 2, 3. Thursday 4, 5, 6. Groups 4, 5, and 6. If there's not enough time, we're gonna use our meeting for field as well. Okay. Yes, modular exam is next week, Saturday. And then we're done. Then oral report, then we're done. You know, I'll think about it. 3 hours, I'll think about it next time. Another question. Explain I. Oh, I is angle of intersection. Oh, by the way, tomorrow there's no class. No field work. I still haven't finished the demo video. So that is actually your last field work for that term. Field work number 9. So I'll probably upload it by the weekend, and then the deadline for the preliminary data sheets will be at Friday. And then deadline of report is on the 11th week. Okay. So yeah, it's the final report for this term. Yeah. Yes, I'm gonna teach Mech 32 next term. Oh wait, before those questions. Well, I question what is I. So once again, I is the point of intersection of the tangents of the two curves, of each curve. This is back tangent, this is forward tangent, this is I. Now if you have compound curves, and you'll see that at some point, wait lang, let's make that smaller. And, okay, this is PCC. So this is your first curve, second curve. Again, angle of intersection of those two is I. But this is a compound curve, so I1. This is your second curve, so this one is I2. And then a combination of that over here where the back and forward tangent of both curves intersect is I. Okay? And then does that explain or reduce your confusion in I? And then for reverse curves, this doesn't exist. Okay, this doesn't exist because the back and forward tangent of those two don't intersect. Okay, this is the back tangent of the first curve. This is the forward tangent of the second curve. If we extend those lines, it's intersecting very far away. So we don't usually use that. So instead, what we have is just I1 and I2. So let's say this is the curve, first curve, and then this is the reverse curve. Like that. Let's draw tangent lines. So this is the tangent line back and forward of curve 1. Angle of intersection of those two is your I1. And then let's draw tangent lines for the second curve. And once again, angle of intersection of those two is your I2. Okay? So just I1 and I2 for reverse curves. Okay, good. No problem. Other questions? Yeah, I teach statics and what do you call that? Mechanics of deformable bodies or more also known as strength of materials. I don't know if I'm having statics next term. I'm pretty sure I'm having mechanics of deformable bodies next term though. And then what else? Coverage of module 2 exam. This. Ah, everything. Coverage of module 2 exam, probably all of that. The entirety of module 2. And then again, no class tomorrow. Saturday, seat work. So no Zoom meeting as well. I'll see you next week, Tuesday. What else? May possibility po ba maging teacher ka namin soon? Yeah, if you get to mechanics, I could be one of your teachers. May central angle pa rin po ba sa compound curve? Kasi po magkaiba po radius. Central angle. Yes. Combined, no. Individually, yes. So the question is there a central angle for compound? Yes. But they're separate. This is theta 1. This is theta 2. Which is also equal to I1, I2. Okay? Central angle and angle of intersection are the same. But there's no like combination I over here. Only up here. Okay? Yeah. Till when completion exam ng statics? Huh? End of term. IP exam end of term for statics. Okay. If I draw a line towards point C, 4731, where is that? Downwards of point C. Okay. If I draw a line downwards of point C, 4731 po yung magiging angle nun. Yes, this is the same as this. It is 4731 because they are parallel angles. What else? Any other question? I'll think about it if our exam is 3 hours. In fieldwork 8, there are 2 trials. Are we measuring the same area in those 2 trials? Let me double check. Okay. Fieldwork 8. Let's see. Oh, really? Okay, I'll check quiz 2 tomorrow. Yeah, yes. Same area. So there shouldn't be that large of a difference for the areas you've computed for fieldwork 8. Okay. I'll check quiz 2 later for those who are late in answering the exam. Yes, I include fieldwork problems in the exam. I'll think about it if you need more than 1.5 hours. I'll announce it next week what the mechanics of your modular exam is. Okay, any other concerns? For the concern on the grades, let me check as well. Quiz 2. Quiz 2. Oh, there. Okay. Okay. Ayan. Okay na. Okay na. No more questions? Okay, we good? I'll see you next week, Tuesday. Since you don't have any more questions, you may go. Bye, class.
Thank you po, ma'am. Thank you po, ma'am.
You're welcome.
Thank you, ma'am.
Welcome.